Okay, now you got to understand what it means, the overall picture. Okay, you cannot do things blindly. You have to understand what this expression means and what this expression means and what this equal sign means. Okay, now what do I mean by that? This whole expression came from a curve y equals to 2x squared plus k plus 2x plus k. So this is a curve. Of course, you need to put y equals something here, and this is a line. Of course, you need to put y equals something here. The reason why there's no y equal to something here is because you have actually substitute one of them into the other, so you're actually solving simultaneous equation here. But this expression actually came from a curve. This came from a line. All right. So when you combine these two together, you use algebraic manipulation. You bring all the terms, and then you make the right hand side equals to 0. You end up with this. Now, although this is the equivalent form of this equation, that means this whole equation is equivalent to this. Okay, this expression here does not represent your original curve, and of course it does not represent your original line. It is more or less a combination of this curve and this line together, and these two are equivalent. That's why you can solve this by solving this, because they are equivalent to each other. All right, so when you try to sub x equals 3 into here after substituting k into 5, you will get this. Okay, this is not the y curve that we are talking about originally. Okay, this is a totally different thing from this equals to this already. That means this quadratic equation does not represent this curve. Whereas you are trying to find where this curve meets this line. So you have to either use this line, which was what the solution did, or you have to use this curve equation. You cannot be using this combined equation. That explains why you cannot use this. You cannot sub into this, and you have to sub into either this or this. You will find that you will get the same answer whether you sub into this or this. Okay, now let's move on to part 2. Part 2, you're asked to explain why there's only one value of k for which y cannot be negative. Now, first of all, let us try to understand this question part by part. This y again does not refer to this combined form, okay? What we call the equivalent form of this, it doesn't, okay? We have to take a look at the whole picture. We are not talking about a line now, we are talking about a curve. So it has to be this one. So that's why I wrote this here, okay? So take note, do not be confused. This is not the curve that we're looking for. In fact, this is another curve, but it's the equivalent form of this. That means if I solve this and I solve this, I'll get the same answer. Alright, but for this particular question, when they're asking you for this y, they're referring to the curve, quadratic curve, and the curve that they're referring to is this original curve. Okay, now that you've understood what y represents, let us look at the question again. Explain why there's only one value of k for which y cannot be negative. Now, what does y cannot be negative mean? It means that your y, which is a curve, cannot be negative. So let's say this is the x-axis. It has to be above is okay, but the important thing is you need to understand, cannot be negative. So can it be 0? Can it be exactly 0? Because cannot be negative means b squared minus 4ac, the condition is less than 0. I think that you know well. We are now asking you, can it also be b square minus 4ac equals to 0? Cannot be negative, so can it be 0? The answer is yes, because 0 is a neutral number. It's neither negative nor positive. So when we say cannot be negative, 0 is included. So the curve can be totally above the x-axis, or it can be just touching the x-axis. That means the x-axis is a tangent to the curve. Alright, now once you know that, you will know that your b square minus 4ac has to be not just less than 0, it can be equal to 0 also. Okay, and if you work this out, expand, manipulate and all that, you will get this final expression, which is a perfect square. Now this is where you need to think, k minus 2 square, can it be less than 0? Can it be negative? It cannot be negative. But can it be equals to 0? It can be equals to 0. That's the reason why, you see, you see, all this while we've been saying, right, a perfect square, and today I revised in class also, can only be greater or equal to 0. That means the lowest value it can have is 0, and that's when k equals 2, right? It cannot be less than 0, but based on what we have done here, it is less than 0. So it contradicts this universal rule, or this law, or this fact that we know. So it cannot be less than 0. That means it has to be equals to 0, which means the only value, the one and only possible value of k, only one, is the only one, has to be 2. Okay, so in your explanation, you need to tell the marker that you know that a perfect square has to be greater or equals to 0. Okay, and it cannot be, oops, I wrote wrongly, okay, because we worked it out to be less than 0, right? I cannot be less than 0. Therefore, k can only, k minus 2 can only be equals to 0. Then of course you remove this square sign, then you will end up with k equals to 2. I hope this explains it. Thank you.